I'm Jeremy. I work on the ArcGIS Online team, JavaScript API team, and I'm here with
Christian, product engineer on the JavaScript API.
And you're a geographer, right?
Yes.
We're both geographers, so we got that going for us.
Yeah.
This session, pretty excited about. This is one that I've always enjoyed, and I used to give this one. Now Christian's mostly giving it, you can do so many cool visualizations with the JavaScript API. Of course in 3D, but in 2D, I think it's pretty spectacular. And let's get started.
All right. So as Jeremy pointed out, first of all, I want to apologize for my voice. It may or may not go in and out throughout the session, so bear with me. As Jeremy pointed out, this is focusing exclusively on 2D, so we won't touch any 3D viz stuff today. But at the same exact time tomorrow, you can get the 3D counterpart for this session in Smoke Tree A through E rooms. So with that, we're not going to look at very many slides. I'll spend the first 10 minutes or so talking about a brief overview of the API, how the renders and symbols work, and how they work in tandem with one another. And then we're going to just dive into some samples. So let's get started with that. So first of all, if you ask us what can we visualize with the API, it's, as Jeremy pointed out, we can do quite a bit, actually. We can do the most basic cases, such as where are my features located? With just a single symbol, they all represent the same thing. In this case, it's world cities. Or what am I looking at? So these are categorical visualizations, as we say in GIS sometimes, or types, you can think of it. So in this case, it's what is the most common educational attainment among each city in Mexico? And so we give it a solid color based on each type. Or it might be how much. In this case, it's an above and below class breaks visualization. So how many people completed a college degree? If it's above the national average, let's give it various colors of green. And if it's below that average, let's give it some kind of shade of purple. We can even do time-based visualizations. And when I say that, I don't necessarily mean like a time slider. I'm talking about a static visual of when. So this can be done with continuous color. It can be done on size ramps. In this case, we're looking at, I believe, road inspections. So if it was, and we could do this, look at this a number of ways. Maybe it's when was the last time we inspected a particular road? Or maybe how old is this feature? And then, of course, we can do a combination of many of those. So in this particular case, we're looking at a combination of color and size. So color is driven by one attribute in your data, and size is driven by another, and you're probably looking for some type of potential for correlation there. And when I say data, we're talking about data-driven visualization. And what I mean by that is you have services, perhaps they're feature services or map services. Maybe you're bringing in other data sources in the form of CSVs, even stream layers. And you can even bring in feature collections, data from other formats, and visualize that. So that's based on field values. So it could be population. We commonly show demographics as examples. But perhaps you have scientific data you can also visualize. There's all sorts of things you can visualize as long as you have that data. So we have in 2D 5 different types of symbols. Making sure no, 6. There's also, no, there's 5, picture fill, okay. So, and the type of symbol you use really corresponds to your geometry type. And with one exception, and I'll talk about that briefly. So with points, you can symbolize them with simple markers, and that's what it sounds like. It's a marker. You can give it color, or you can use a picture or some kind of icon to visualize your points. With lines, you have a line symbol that you can style in a number of ways, mostly with color, and there's different patterns you can use. And then you have polygons, which you can actually have more than just these symbol types. You can visualize them with fills. Also, you could do a picture fill, so to do some kind of pattern inside each inside each polygon. But you can also apply marker symbols to their polygons and place those in the centroid of your polygon. And we're going to show examples of both of those. You'll notice throughout that the API for creating these visualizations is actually quite simple. They're simple objects. So the simple marker symbol, you can set a style. So in the case of this green icon, we say diamond. You set an outline property to indicate the width and color, and then the color of the inside or the fill of that. That's really all there is to it. There's not much else going on there. The real difficulty with the visualization, as you'll see throughout the session, is actually determining what those colors and sizes are. But as far as setting those with the API, it's pretty straightforward. Same as the case with the simple fill symbol, but obviously we don't have a size there. And so I already alluded to data-driven visualization with field values. So you can set a object on your layer to style it. We call it the renderers. And then inside that render, you reference this field value. And we'll go through code snippets showing that. But you also have two other options at your disposal, which can be very powerful. One of these is arcade expressions. It's a ArcGIS platform expression language that works throughout the platform. So not just the JavaScript API, but you can use these in ArcGIS Pro, the runtime APIs. You can save them to web maps, to layer items in your portal, and it will read that expression and understand it throughout the platform. So it's a really powerful way to drive your data. So you could do something like this, where you want to show people with advanced education, perhaps it's the population, rounded to a certain decimal point. And so you can do that with your arcade expression. You don't need to create a new field in your service and recalculate it if you don't have to, though that may be a better option in some cases. You can also use JavaScript functions, and this gives you even more flexibility than arcade. However, note that if you use JavaScript functions to drive your data, so maybe you want to bring in other data sources, or you want to use client-side geometry functions in certain cases that you don't have in arcade, you can do that with a JavaScript function. However, be aware that, excuse me, however, just be aware that that is not persistible. You can't save that to a layer item or your web map for security reasons. Is there anything else you want to add to that, Jeremy?
No, that's good.
Okay. So moving on to the renderers. In the 4X API, we support these three renders: the simple render, which is the case of where's my data; unique value, which is exclusively for types; and then the class breaks, which is exclusively for number visualizations. Now, I was sort of misleading on the simple render. It's not just location. You can also do data-driven stuff with that as well, and I'll get into that. So these are what the renders look like. Fundamentally, you set your symbol inside the renderer, so it could be that simple marker symbol, it could be that simple fill or simple line, and then you have, in the case of class break infos, or unique values inside a unique value infos object. And notice in the case of this unique value snippet, I'm not using a field value, I'm using an arcade expression to, in this case, it looks like I'm trying to see who has the most votes of a particular political party. So you may not have a field in your data that indicates that, but you can use arcade to figure that out for you. And the last thing I wanted to cover with the renders is the concept of visual variables. We'll go through this heavily throughout the session in our demos. Basically, you have these four available at your disposal: color, size, opacity, and rotation. And the general idea is that these are not intended for class breaks visualizations. They're all for numbers in your data, but you want to use some kind of continuous ramp. It could be a continuous color ramp, which is the case of this image in the middle, this pale yellow color to the purple. Or it could be a size. So you have small icons going to big icons to indicate maybe a total count. You can even use opacity, rotation, and combinations of those as well. You just need to be aware that the more combinations you add, the more confusion you're going to add to your visualization. But
Maybe leave it on that one a second.
Yep.
When we started, and probably what most of you who came from a cartographic background are used to, is the traditional class breaks, unique value type and in certain cases can be useful, but those are rooted in the print technology. With a class breaks visualization, it's pretty complicated to decide what you're supposed to do. So how many classes do you have? Do you do 4 classes or 5 classes? What's the difference between, why is this one yellow if it's 39.6 and this one is red if it's 39.7? And it's even more complicated if you start to think about with class breaks and you say, I want 5 classes. How do you statistically break up your data within each of those 5 classes? Do you use patterns like Jinx natural breaks or quantiles or standard deviation or equal interval? Those are pretty complex things to think about. And as a developer who's writing an app with a specific visualization, if you know the values that are important, that's always going to be the best, and you can use that. But if you don't, then using something like a visual variable is going to be easier to understand and not force some predefined classification on top. Classification is rooted in print cartography. If you print out a map, I need to be able to look at the map and see the color blue, and then go to the legend, find the color blue in the legend, and pick out what its label is. You can only really tell 7 or 8 different colors apart, so that really limits you. But in the digital world, if you want to know what the value is, you just touch it and the pop-up tells you what it is. So that's where these visual variables, which Christian will go into, really expose a lot of the power. And then at the end, we'll show how we've taken this substrate of information and built the smart mapping experience in online.
Yep, thanks, Jeremy. So in code, the visual variables essentially it's an array of objects, and each object is a different type of visual variable. So you'll note that this is within the renderer, it's not on the symbol, and you set the type. So if I want to do this continuous color visual, I just say, this is type color, this is the field I'm using if you're normalizing it, which is usually a good idea. So in the case of this, it's the percentage of the population that falls below the poverty line. You set those data values, and then you have the stops. And so within the stops, you can say at the lower end, if it's 10% or lower, then I want to use this yellowish color. And if the poverty population is 30% or higher, I'm going to give it a purple color. And then the renderer will take over and interpolate between those values and put it along a continuous ramp. So you get those nice different shades between yellow and purple. And I just wanted to point out before we dive into the examples that there are other render types in 3x that you might be familiar with, such as heat maps, dot density. We've experimented with blend a bit. Heat map and dot density for sure will be coming in 4x. We still need to look at use cases for blend renderer ultimately. But know that those will be coming soon.
Should be in 4.8.
4.8, okay, cool. All right, so let's go ahead and dive into some of these examples. I'm gonna just end this show so I can see what I'm looking at. Okay. So before I dive in, I just want to point out, I'll show this later. This is a repo I have on GitHub, so you can access all of these demos and these slides by going to my profile, Conferences DS 2018. This is where all my sessions are as well. So just go to 2D-viz and you'll get access to these. So I should have decent descriptions for these, or halfway decent. All I need to remember kind of what we covered today. And of course, you can find this information in the documentation. So if you go to the guide, we have this visualization tab. By all means, check this out. We have an overview talking about all of these concepts that we're talking about today. And it points you to the samples as well. We have probably over 20 samples just talking about visualization. And the majority of those are 2D visualizations. And if I need to blow up my screen, then just let me know if you can't see very well. So in this case, we're looking at CSV data from the USGS, last 7 days of earthquakes throughout the world. It's a simple visualization. All I'm looking at is the location, right? In code, all I'm doing is I'm bringing in that CSV data, and I put that URL in a CSV layer. I'm setting a pop-up template too, so if I click on these not hurricanes, sorry, earthquakes, I can see some information about it. Let me blow this up a little bit. There we go. Now I can set the renderer on the layer by simply saying dot. I call the renderer property, and then I can make a simple renderer. So that's all that's going on here. I'm setting a size to 10 pixels, giving it that red color with a thin outline. And I also want to point out that in the 4X API, we support autocasting for these, so you actually don't need to import your simple render and simple marker symbol objects. You can do something like this, get rid of this, and then set the type to simple. And I can set my symbol type to simple marker and make sure that I don't have extra parentheses. So now those modules are no longer imported by me. They're just already imported in the application when I autocast, so it still works. So that's designed to help assist you in making this an easier process. You don't have to import a ton of modules like you have to do for 3X. So let's add some understanding to our data. So I have these two objects here. One of them is a color visual variable. As you can see, it's just a simple object. I set the type to color, and I'm referencing a field value. I got this from the data set, so I know there's a magnitude field, and I kind of can approximate how many or how big some of these earthquakes are, but let's do it along this color ramp and see what we get. So all I have to do is set the visual variables property, save it, see what it looks like, and we get something like this. Pretty cool, but we can kind of see some patterns here where, about north of Japan, there's some bigger earthquakes. With icons, I tend to favor size. So let's take a look at that. Instead of setting the color, it's the exact same object with the exception of in the stops, instead of color, I say size, and I set my type to size. So in that case, we'll get a different looking visual like this. So really, it's quite simple to play around with this. Let's take a look at another example. This time I have a feature layer. It's of Mexico municipalities, and it has a bunch of education variables. So I want to explore some education data. So here I set a pop-up, and I have this field in here that I think is fascinating. It's the number of people in the municipality that have never attended any school. Like no preschool, no kindergarten, no nothing. Because they have all of these attributes in there. It's so detailed that it says how many people attended some preschool, how many people attended some elementary school. So it's a very detailed data set. I love it because I still discover some interesting patterns in there. So I'm going to take a look at that attribute. Previously, you had to set the outfields in the feature layer in earlier versions of the API in order to download that data. Now the renderer will do that for me. So I no longer need to do that. It makes my coding experience easier. So this is the variable that tells me the number of people that didn't go to any school. So this is not accurate, so I'll say total pop, or just the population that didn't go to any school. And so I set my stops in a similar fashion, and in my renderer, I'm setting a simple fill symbol, and the visual variable will override the style and the color. I don't like the thick outlines, so I can change this. Maybe I change it to 0.5, or I can make the opacity something a little lighter. So when I add my visual variables, I'll get something that looks like this. Now, some of you out here are probably geographers, and you will say, well, hold on a second, this is a misleading visualization. All I'm really seeing is a population map. And you're correct. this is something you shouldn't be doing. Because this is a total count, we get this distorted picture that looks like municipalities surrounding Mexico City tend to have more people, or a higher rate, I guess you could say, of people that didn't attend any school. Well, it's true that more people there didn't, but throughout the country, we can see different patterns when we normalize our data. So we can use the normalization field, which is this education base. It's the total number of people that were included in these education variables. And note that we'll have to update the stops because now we're looking at dividing those two values together. Oops, we want this one.
Christian,
Yep.
where did you get those stop values? Like, how'd you come up with them?
I got them from smart mapping, which we'll talk about in a few minutes.
Okay, cool.
So what Jeremy's pointing out is the fact that, well, I might be up here saying, hey, check out this simple visualization API. We can do all this powerful stuff. And you might be shaking your head saying, I have no idea how you came up with those values. How do you even know how to pick those nice looking colors? That's where smart mapping comes in and helps out. So we're trying to make it as easy as possible for you guys to create powerful visualizations in a matter of minutes, really. So without smart mapping, I would be just guessing, picking numbers and refreshing and just seeing what works. And that can be a very time-consuming process, as I'm sure you all know. And so when I update those, I should see a different pattern. And now I see something a little more interesting. These outlines still bother me.
I was going to ask you, about the outlines. What if you took the default of 1? What would it look like?
The default?
Yeah.
Looks like this.
Yeah. As Jim Harris would say, your outlines will make or break your map.
Yeah, so I'm going to bring that opacity down even more. There we go. That's a lot better.
Yeah.
We can still see the different boundaries, but they're not overpowering my visual.
One of the number one flaws in most maps is a really thick outline, or maybe you use the same outline size across all scales, and all people see are the outlines. They don't see the colors. And it gets worse, of course, as you zoom out. If you zoom out far enough, you shouldn't have any outlines at all.
Right.
And you'll talk a little bit about that, right, with the outlines?
Yes.
Yes. Sorry.
So yeah, this visual looks a lot better now. Now I see patterns. They tend to be rural areas. Mexico City's not dominating like I didn't expect it to. The only thing that still really bothers me is the legend. If I change the text to say the percent population, the numbers don't really reflect true percentages. So something you can do is use Arcade to help you out with that. So here's my visual variable. So instead of using these, Arcade expressions are set in the value expression property. And it's just a simple string value. So I can use the out-of-the-box Arcade function, such as round. And for those of you who are unfamiliar with Arcade, I strongly encourage you to attend mine and Dave Bayer's session on Arcade tomorrow afternoon. It's either this room or the one next door, I believe. We're gonna go deep into some of these samples and showing how Arcade can be powerful for visualization, but also how you can use it in pop-ups and labels and other aspects of your apps. Yep.
Just turn it on. And you just go to developers.arcgis.com/arcade. They'll give you an example of all the functions that are available for you out of the box to use with Arcade. It's supposed to be like Excel type expression language. And yes, definitely attend Christian and Dave's session tomorrow.
So it provides you with all these out-of-the-box functions that you can pass in these values and just generate new values on the fly. So in the case of here, I'm still going to follow the same basic formula. The way you reference these variables is using this $feature global. So I'm going to say $feature, that variable divided by the next variable. Let me move this over so we can see better. And let's make this look like a percentage. So I'll wrap these in parentheses and multiply it by 100. maybe I'll round it to 1 decimal place, and that should work. Now I still need to update my stop values, so instead of being like that, I'll move it over and have a nicer looking legend. So there, I'll say percent up here in my legend. So I should see the exact same visual as not setting the arcade. There we go. And now my legend looks a lot nicer. So that just took a couple minutes to do in code. And as Jeremy pointed out, picking those values can be a different matter. But we'll talk about that in a few minutes. Let's look at another example. So this is I'm not going to dive too deep into this one. The purpose of this sample is to show you or get you more interested in arcade. So this uses a more complicated expression, so to speak. So if we look at the code, what I'm doing is the expression is much longer, so I'm actually setting it in a separate script tag with an ID. And what I'm doing is I'm looking at all of these education attributes that I have at my disposal, and I want to see which is the predominant education level in each municipality and visualize that. And so because some of these are so detailed, so in the case of maybe someone didn't complete secondary school, but they did some, I'll put them in primary school and categorize them that way. So basically I'll write this expression, and so it should return one of these values. They didn't attend school, they attended preschool, but didn't move on, and then so on and so forth. So you can see it's a little bit longer, about 20, 25 lines or so, and it will return a value for me. I also have another one telling me the strength of the predominance. Another way you can think of this is, in the case of election map, it'll tell you the share of the winner. So I'm not going to set that on my renderer yet, but I'll do it just to show you the difference between the two visuals. This arcade expression infos is used exclusively for the pop-up, so you'll notice that I'm going to get my arcade text using just the DOM. And then I'll set that reference it in my pop-up template, so you can reference it using that syntax. And also in my renderer, I'm going to set that same expression on my value expression. And note that you also have this value expression title for the legend. And because it's a unique value visualization, I just created this simple helper function to give me a simple fill symbol based on a particular color. And so I'm going to colorize each category or each feature based on these categories. And this is what I get. I see some interesting patterns where there's a lot of places, probably rural, where they didn't complete elementary school. I see in the cities that there was a lot of elementary school completed, and in other rural areas they actually completed middle school. But then I see this interesting pocket down here of areas where they didn't attend any school is the predominant value. In the case of this guy right here, over half the people didn't go to any school at all. It's super fascinating to me. But again, we can use visual variables to our advantage to perhaps provide additional insights. So how strong are these trends throughout the country of Mexico? And so we wash out some of the colors just to show, yeah, that may be the predominant value, but there's other areas competing very strongly with that category. So while high school may be the dominant educational value, there's other ones that are competing with it. But you'll notice that that same little area is still pretty strong. So again, interesting story there.
So so in that case, Christian, you had a unique value renderer, that then you also applied a visual variable?
Yes. So it becomes a multivariate or a bivariate visualization. So it's not just one data value, now I have two data values driving it. And really in the case of arcade, those values are generated client side because I'm using something like 16 attributes to give me one value. So that's how powerful arcade can be for you. This data isn't current, as you can see, it's 2012 election data, but it's always relevant every 4 years or so on a presidential election in the United States. So let's say we want to map the results of a presidential election. In the United States, it gets complicated with the Electoral College, so I'm not going to map districts or states to show the winner of the electoral college. Let's say I just want to look at the popular vote. In the case of a popular vote, this is not the best visualization because it doesn't tell it tells a very misleading story. Now, on the other hand, if I want to tell you who won the most counties, this is a very accurate map. This will tell you that story of who won the most counties. In this case, in the case of pretty much every election, it's the Republican candidate. And because this also follows that same unique value renderer pattern that I just showed you. So I have this create symbol helper function, and I just set two values, Obama or Romney. There's other candidates, but we know that it basically came down to those two. So how do I make this map tell me a more accurate picture of what actually happened as far as total counts go? What I can do is use visual variables to create a multivariate visualization. So let's look at opacity first. Let's say I want to use opacity to my advantage, and I'd say, okay, I want to see who won the largest share of the vote, kind of like what I just showed you with the predominance. So there's actually a field that already tells me that in my data set. I don't need to use Arcade. So it says %winner, and I can put nice text in my legend telling me what that variable means. And then I can set my stop value. So in this case, I'm just doing 2. If they won with 50% of the vote, I'll make it pretty pale and say, okay, you barely squeaked by, you still won, so we'll see that little shade of red or blue. But in the case of maybe you won with 75% of the vote, that's a huge win. So we're going to give you a pretty solid color. So let's go ahead and add that as a visual variable. Okay. So you'll notice that when I refresh this, you'll see a lot of the same pattern, except that some of the areas tend to be washed out. You'll notice that this area of blue counties won by President Obama are now washed out. See, they were clearly highly contested counties that probably already leaned Republican that he happened to win in that election.
Christian, I have a question for you. How do you have to stick with the values that are in the opacity visual variable? Or can you put your own legend values in?
I'm not sure what you mean by that.
Like instead of having 50 and 75, could you actually put a label?
Yeah, you could, absolutely. So if I wanted to say add a % symbol, you actually have this label property of your stop. So I could say 50%.
Or you could even say something like close race.
Yeah, absolutely. This was highly contested or landslide. Yeah. We could do something like that. Contested landslide. And that way people don't have to be confused wondering like, okay, so this was 50% or 75%. So now I can see, oh, these were highly contested, these weren't. That's a better idea. So, okay, I see a new picture. But something I basically learned is, wow, there's a lot of rural counties that are very strongly voted in one direction. There's not a whole lot of variation there. And in the case of the blue counties, they didn't win very strong. And as you know, the urban counties are going to be the ones that voted strongly for the Democrat, but we don't really see that in this map. The geometry, for those of you geographers, we learned that the geometry tends to dominate because the size has a higher visual impact. So we want to get past that, and the way we do that is instead of using fill symbols, we can set marker symbols. And the idea of a marker symbol is once you do that, all the geometries now have the same size, the same shape. So they don't fight with you on that one. So in this helper function, I changed it a little bit to say, okay, is this a marker or not? If it is, give me a simple marker symbol. If not, make this a simple fill symbol. So I'm going to go ahead and make these markers and see what it looks like just on its own. So now the geometry shouldn't be fighting against me. These are still pretty big markers though, but now they all have equal size. So the blue tends to come out a little bit more. But that still doesn't tell the whole story. So I'm going to make another visual variable for size, and base it on this other field, which is the total voter turnout, give it that nice label in the legend. And again, I sort of arbitrarily, I didn't use smart mapping here, I kind of arbitrarily said, if this county only had 100 votes, it doesn't really mean a whole lot in the context of the national election. However, if it has 1 million, that's a different story. It's got a lot of votes to it. And so I map those sizes to those values. You notice I didn't use stops here. In smart mapping, we tend to follow this pattern for size, where you have a min and a max, and we just interpolate between those two. So let's go ahead and add that.
And while Christian's doing that, you might think, well, why not just do the whole range, min to the max? But with count data, you are really susceptible to outliers. So that'll really drive the entire visualization. You'll just see the biggest one. And maybe it's important that if it's over a certain threshold, you can just all consider them big, and you're more interested in sort of the variation in between. So that's what that min data value, max data value will get you. Anything bigger than that value, you'll just get the max size. Anything smaller than that value, you get the small size.
Yep, absolutely. So now you get this picture of the popular vote of the election. Now we see that the blue tends to dominate more, and that's what happened in this particular election. President Obama happened to win more popular votes than Romney did. So, granted, still want to say that you got to question all these visualizations and make sure and take them for what they're worth. I mean, the popular vote, again, doesn't mean a whole lot. It's the electoral college that counts. So just make sure that when you create visuals like this, that you make sure that that's communicated clearly. So another thing too that I notice as I look at this is while the blue tends to dominate now, that still doesn't tell what actually happened. I mean, this was still a fairly close race. It wasn't like it was a complete landslide. So the accumulation of all these small red dots with these fewer big blue circles doesn't really show how close it actually could have been. So just wanted to point that out as well.
And we're not showing you this because we think this is the best map. This is just one way to visualize it. It really gets down to the story that you're trying to tell with the data that you have. What's most important? What do you want to highlight? These all factor into your choices on how you pick the right visualization technique.
Absolutely. And the same holds true for smart mapping. So as Jeremy pointed out, okay, this is a cool API, it's powerful, but I'm not a cartographer. How do I know which colors to use? How do I know which data points to map to each of these colors? That's where the smart mapping project came from. It's aimed to help solve that issue. As Jeremy just said right now too, it's not aimed to give you the best visualization right away, but it is supposed to give you a pretty good starting point. So you can immediately see patterns in your data that you might not otherwise have been able to pick out in just a couple of seconds. And it also gives you some pretty good colors to start with. Just to give you a demo, if you're familiar with ArcGIS Online, then you've probably already seen how this works. But in a custom app, you can do the same thing. Say I want to visualize based on the percentage of the population that voted for President Obama. And I immediately get a nice looking visualization. Again, this may not be what I want. I may want to use a blue color scheme or something for whatever Democrats typically use. I may want to do an above and below to show where maybe if I set this at 50%, I can set the slider up and show where he tended to win versus Romney and things like that. So you can hook in these nice like slider widgets that work very nicely hand in hand with the renderer. Basically, the slider widget takes a visual variable and it uses these values to spit out a new visual variable. So each time I slide this, I can set that new visual variable right back on my renderer, and I can update it very quickly like this. And we can do that quick visualization because now we can render feature layer with WebGL in 2D. So it makes for some pretty slick data exploration applications.
Could you go back to that one, Christian, and pick up a different variable?
Let's go unemployment rate.
Yeah. So as you see, as he picks different variables, that breakpoint for above and below goes to different places in the data spectrum. And that's because, maybe go to something not quite so skewed.
But yeah, looks like it's kind of bad data too. 4,000% voter turnout.
You found it. No, just kidding. Sorry, bad joke. Anyway, so why do we pick these stops here? For the unclassified color and size, we're using the distribution of the data, the average values of the data, the summary statistics, the standard deviations, plus or minus, to help set those stop values. And it's just a starting point, like Christian said, and you could explore different patterns based on whatever story you're trying to tell.
Yep, and you'll notice that we have different color schemes based, like categorized by theme. So if you want to center on a particular value, maybe it's this independent, let's see, they identify as independent, and you're on one of the two major parties and you really want to go after them. So maybe you want to center on, I don't know, like a particular percentage of independence in a particular county. You can use these to your advantage in that way. Also note, let's go back to unemployment here just to see what we can look at. I also want to point out too that the color scheme depends on the base map, right? Because this color scheme probably isn't going to work for a dark base map. So if I were to change it to a dark base map, smart mapping will give me something new. So you'll see all these colors update on the fly. So you get good color schemes per base map. And I think that's pretty cool.
And the color schemes are, most of them, if not all of them, are colorblind safe. Most of them, not all of them. And they're also, we worked with Cynthia Brewer. It's sort of the next generation Cynthia Brewer ramps. And then we've also got some very talented color cartographers within Esri who contribute to this, Andy Skinner and others.
Yep. And so notice that I can also use smart mapping to do these multivariate visualizations, so I can add size to look at maybe this potential for correlation. So areas where had high unemployment rate but voted for one candidate versus the other. And we see that varies based on the geography, but that's what's exciting about it to us, right? Is we're making these applications so that we can learn something new spatially. And notice that I also see kind of this nice histogram on the slider as well, telling me how my data is distributed.
Size is a complicated beast.
Yeah.
Go full size,
Yeah.
where it's at 0. When you spread your data, and if you have a nice normally distributed map, size is very complicated to visualize, and because everything becomes fairly big, and it takes up a lot of space, and then it occludes each other. Includes the features are occluded. So what is interesting to do with size is to take size up to maybe the average. And you really want to use size to call out what are the biggest values. So if we made that one the average value, then we'll say everything that's the smallest size is the average value or less. And then we're really looking where it's above average. And then that lets you focus in on those areas that are most interesting for this data set.
Yep, absolutely. Before we move on, just want to show really how simple that API is. All you have to do is give it these parameters. So you give it your layer, tell it what base map you want to use, and then the fields you want to map. And we don't need the view here. This is if you're using arcade expressions. But if you take the view out, and we have a default theme that we use. It's the high to low. So it's really just these 3 parameters, and we'll query for the stats, get those back, and give you a visual variable that will make sense for your initial look at it.
If you have an arcade expression, do you still get stats?
Absolutely. We calculate those on the client. And that comes, that's already there in the 3x API, and that is coming in 4.7, this API, which is coming out in the middle of April or towards the end of April this year. So you'll be able to use those arcade expressions that I showed you and calculate stats for those as well. So really powerful stuff with this API that you can do.
Christian, I forget, are you going to show the size as you?
I don't have a sample for it, but we do in the documentation. So if I look at the sample code.
Getting back to the outlines, where the outlines can really get in the way.
I guess this is a different one than what you're talking about. You're talking about polygons, right?
Yes.
Okay.
And sizes of. of circles.
Yeah, you'll notice that as I zoom in and out, oh, it should be changing. That's not good. Oh, there we go.
Yeah.
Yeah, you'll see it change in the legend.
Yeah, size is complicated because if you have one size value and you expect it to work across all scales, it's probably not going to be true because as you zoom out, everything cover everything else up, and as you zoom in, they'll become so small that you can't see them. So what you can do is have different size values based on the scale of the map.
Yeah, so you do that within the size visual variable. You can set an object on the min size and the max size and map particular min and max sizes to specific scale values. So at this point, it starts to really get into the weeds of, oh wow, what size really makes sense for this scale? And so to pick these values out on your own, it's a pain. I've tried doing it and it's not fun. So smart mapping has the functions that allow you to do that. And a lot of the time, it works the same across all data sets. So once you have it once, you can just apply it everywhere.
Yep.
And the same is true for outlines of the polygons. You can set that outline width based on scale values. And as you saw in the plenary, we also have clustering options available. This is only in 3x for now, coming in 4x later. So you have these dense point data sets that now you can cluster, so you can gain additional understanding that isn't otherwise apparent when it's all cluttered and stacked on top of one another. So many of you probably have data sets like that. So this is a very useful technique so that we can more easily visualize our data. And what I like about it is that the renderer of the layer is completely separate from the clustering. So we're able to summarize our data this way. Yeah, okay. So, and then that's true of when you add filters on your data. So if I want to filter on something like consumer complaint, I can see the time of day that those tended to happen, or blocked driveways. I can see that this part of the city tends to have more blocked driveway complaints, probably because more people drive than in Manhattan. And they tend to happen in the evening and in the morning, maybe when they're coming to and from work. So you can see some interesting patterns come out with clustering.
And since clustering, like Christian said, is a layer property, whatever visual variables that you have already on your map are going to show up. You know, basically, you're going to get the average values. So you can create your renderer just like you were working off the points, and then turn on clustering. And the renderer is still good because since it's working with the average values within a cluster, you're going to get it's whatever style you already picked will just apply. And it also helps as you zoom in and you can get to the place where you no longer need to cluster the data and you just show the actual points. So you simplifies your life by just having the one renderer defined on that layer, which works with clustering or without clustering.
Yeah. So I'm going to go ahead and turn it over to you. Talk about your stuff.
See if this stops feedbacking. Just wanted to go through a few example maps to just kind of show you where they come from and based on what you just saw with Christian in ArcGIS Online. So here's a map of metropolitan areas enriched with median household income. And if we look at the style, it's counts and amounts color. What that actually means is it's a simple renderer with a visual variable of color where 3 stops, where the center stop is white and it's at the national average of 59,000. Or excuse me, which is, I'm not sure where Jim got this number, but the average in this data set anyway is 44,000. And 2 colors above and below. So it's the same example that Christian showed is happening here. If we go to this map, we're using a size visual variable and an opacity visual variable to drive both, to show you the population, to actually reinforce the same information. So we want to reinforce where older people live in this map based on, I think this is census tracts. So using both size and transparency or opacity to make that calculation. This one uses all three, color, size, and opacity. Same as the previous map, but then also instead of having a single color, focus on the percentage of people that are above, that are 65 years or older. So that really highlights areas like this area in blue here, where it's a very high percentage of the people are older, and there's a lot of people who are older, versus some of these areas downtown where there's not quite as many people, but still pretty high percentage. Again, if we were to, let's look at this here. Look at what's in this web map. Okay, so this is the web map, and shoot, which one of these is it? Yes, I think. Not this one, sorry. There we go. This might not be exactly the one there, but we have this visual variable with this field, and it's got a set of stops with a specific color. Oh, it's the wrong one. Dang it, sorry. One here. Variables. Ah, here we go. I think this one's it. Okay. Yeah, there we go. So we see here, this is the color one, and we see the same basic structure that Christian showed you earlier. The color visual variable with specific stops and specific colors, which match to what's displayed here in the map. And the same thing for size and opacity. Here's one which shows you whether sales is Houston sales tax payment change has increased or decreased, and then what's the magnitude of the change. So using a unique value type-based renderer for increase or decrease, and then using size to give that relative weight or importance. Or this Utah road safety index and crash analysis that combines two things, a color and a size, but in this case the size is based on the lines. So we make the lines thicker based on the average daily traffic. And then the roads have also been classified with their safety index. So if you've got to highlight certain areas that have lots of traffic and have a high safety index, this is a good map for that. Also work with dates. Dates can be treated almost like numbers if you think about it. So this is a good map that shows you what have you done for me lately, showing you all the roads and when they were last inspected. So roads that are white have been inspected relatively recently, and roads that are darker purple haven't been inspected in 10 years. And in this case, it's also using opacity to reinforce that. This is a predominant category, so similar to the arcade expression that Christian showed. If I look at the style, it's this predominant category and style, and then the smart mapping will set all of everything up for you. So it highlights, creates these colors based on what's the most common in that area, gives you the sum so you can see what's the biggest, who has the most impact, what's the largest numbers. and then uses opacity to define the predominant strength. This one combines all three visual variables. Actually two, sorry. Size, which gets bigger based on the number of votes, the arrow. And then the direction is defined by who won, or how much the person won by. This is one uses an arcade script. So if I go in here to, I've got this rotate symbols based on this expression. This arcade expression basically normalizes everything to 0.9 and minus 0.9. So if you were completely Democratic vote, the arrow would be facing that way. And if you were completely Republican vote, the arrow would be facing that to the right. So in a straight up and down is a fairly close election. Rotation is also an interesting variable to use when doing thematic mapping. This one's a pretty interesting map. We've got different layers, each representing different populations within each county based on ethnicity. So we look at this Hispanic, and what we've done for all of these is actually normalize them to 20%. So if the population for that particular group is above 20%, then it gets full color, otherwise it fades out. And pretty interesting, it's a percent of total map. And when you start to compare multiple variables, you can really get some pretty interesting patterns. So in this case, it's actually a fairly simple visual variable that you're doing. You just got one color and one opacity visual variable that you've normalized to the same value. And based on how this data is, if you overlay them, usually don't have two highs in the same area. Or to do things like a ratio map. This compare style is really just a normalization of the data. Normalizing it either by as a ratio or as a percent of the total or as a percent of the other variable. So yeah, and I think we're at the end. Do you have anything else? Yep.
Just really quick, I wanted to show you that you also have this resource at your disposal, the symbol playground, if you haven't heard of it. So you go to the JavaScript documentation, click sample code, and just search for playground. You have this app, which is really cool. You can click on different symbol types, and you can see it update in your view. So here we don't see very clearly where the symbol is, but when you change the color, you can change the opacity, there we go, and maybe the size, something bigger. So once you do that, you can copy and paste that code and put it into your app. So it's a really useful tool if you're just looking for something quick and dirty to get started. And just in closing, I wanted to encourage you to rate our session. Let us know how we did as presenters, and also let us know if the content is relevant to you and your work, and if there's anything we can do to improve to help you out. And with that, we got just a minute to take one or two questions. So, yes. Yes, I can go ahead and show that.
Any others?
Well, the preferred, so, and what type of, are you switching renders quite a bit in your code, or are you just setting one? Is it on a feature layer? So the preferred way is if you're just visualizing it one way, if you can save it to your layer, and then that way you're not setting it in code. So you can just load it that way. If you're using a portal item like ArcGIS Portal or ArcGIS Online, you can save it to that layer item as well. And we talk about that in the guide as well. That's the preferred way to go. I mean, while we have a simple API, by all means, just save it on your layer, bring it in that way. But if you have to switch it in code, then I think it really depends on the application and your workflow. So.
Over at the end.
Not yet. So these sliders and our 4x API, they're still using the former widget pattern right now. We're hoping at 4.8 to migrate that to the new framework that we've worked on for our widgets, in which case you have more flexibility with customization. But I'm interested in your case, so if you want to chat afterward, we can talk about what your requirements are so we can see how that would work out. But yeah, in the current state, we don't provide anything to help out, but I think that there is potential for that coming.
Yeah, but I would be careful. Those aren't really meant for just general charting. We might have charting in the future. Yeah.
But yeah, you could. We do provide the API for generating that histogram though, so you could do something with those stat values in your custom.
And then, did you have one, sir?
Well, I thought in the documentation that I saw, our feature layer, we're only allowed 1,000 feature points. Is that still accurate?
Are we limited to 1,000 feature points? No. Yeah. Cool. Well, I think we're at time, so just come on up. We'll answer questions.
Yes.
Thank you.